Alright, this is one for translations. Your objectives, you'll be able to draw translations and draw translations in coordinate planes. Now before we get into that, I want you to think, what do you know about movies or slideshows? Well, to make movies and slideshows, more importantly more movies, to make something look like it has movement in it, it takes multiple pictures and how fast you go through those multiple pictures. This involves what we're doing actually with translations. Translations is a bunch of pictures and just captions of movement. To explain a little bit better, let's say you have Link and his sword. To capture the movement of his sword being moved up, it's a bunch of pictures being rotated together. And they're being moved, going through the pictures so fast that it looks like it's a sword moving up. So if his sword was down here, we get a picture here, 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 and here. And it's just the pictures going really fast, and that's how you create movement in movies and pictures and things like that. Same concept here applies with basketball. How can we mark things off and add statistics into basketballs? Anytime the ball is moved or passed from one player to another, that's considered a translation, going from one place to another. Alright, so you got one for translations. Connect 4. What's another example of translations with the pieces sliding down and the Connect 4 board? Anything to do with movement. So it moves. So this camel is placed right here. And if we move the camel, that's a translation. Alright, so let's talk about it algebraically. Let's say you're given a coordinate, x, y, or better yet, let's give the coordinate +3, +4. If we're going to move the figure, or this 0.34, anything to the right, I would just say x plus the number I want to move to the right. So if I have an x plus 5, that's saying I'm going to take this coordinate 3, 4 and I'm going to move it 5 to the right. So anytime it's x plus a number, it'll be moving to the right. And how many spaces? Well, that refers to the number. Now when we do y plus a number, let's say y plus 2. That's saying I'm moving 2 up. So y plus means up. So y plus 2, that means you're going up 2. So if we have the coordinate 3, 4, and I'm moving to the right 5 and up 2, we do 3 plus 5, which gets us 8. And 4 plus 2 gets us 6. So that coordinate 3, 4, if it goes through the transformation or translation of x plus 5 comma y plus 2, we're going to result, or that 3, 4 coordinate is going to wind up at 8 comma 6. Now if we do x minus a number, that means we're going to be moving left, and y minus a number means we're moving down. So if we have the coordinate 5, 6, and I want to say x minus 1, meaning I want to move it 1 to the left. I do 5 minus 1 to get the 4. Now, y minus, that means we're going to be moving the picture down. So y minus, let's say 5. So we take that 6. 6 minus 5 is 1. So that coordinate 5, 6 it goes through the translation of x minus 1 comma y minus 5. So that means we're going to move it 1 to the left and 5 down. And 5, 6 going through that translation as a result of 4 comma 1. And xy goes xy. Let's say you have the coordinate 5, 7. Xy to xy just means it's not going to move at all. So 5, 7 stays at 5, 7. So when you're working with like video games and you're creating movies in the video game, if you want certain pieces to move, you'll be typing in these certain translations, x plus 5 comma y minus 10, to move the figures around, different points of your figure to move around. But if you want something to stay in place in your video game or movie, you do x, y, dot, dot, x to y. So meaning it's a no move. Like the base of the sword doesn't have to move when you're rotating a sword. However, the tip of the sword, the pointy end of the sword, if you want that piece moving, you would have to do the translations for that piece. Alright, so translations. Translations in a coordinate plane. The translation is a slide of a point or a set of points or a figure. In order to slide the figure, you move the figure the number of spaces in the direction it's indicated. Just like we were doing before. Look below for an example. So in a figure, quadrilateral DEFG, so this blue guy, has been translated 5 units to the left and 3 units down. This can be written as XY, our original coordinates. We subtract 5 from our X values and we subtract 3 from our Y values. And here's what each little coordinate will look like. Here's your original coordinates, DEFG. It goes through the translation, which is right here. And then the end result after that translation is D prime, E prime, F prime, and G prime. Let's do a couple more examples of this so we get comfortable. So Q is in the coordinate 2 to the left, 0 up, down. So that's where Q is. We want to move Q 5 to the right and 5 up. So 5 to the right is 1, 2, 3, 4, 5, and then 5 up. So now Q prime is all the way up here. We do the same for R. 5 to the right, 1, 2, 3, 4, 5, and then 5 up. This is the location of R prime. P is 5 to the right, 5 up. I think I miscounted. Yes, I did. Right there. P prime. So that red triangle is Q prime, R prime, P prime, aka the answer that we're looking for. So our picture, we match up the picture and we see that it's C as far as A, B, C, D with the multiple choice. Alright, here, looking at number 2. Graph the image of the figure using the transformation given. So the translation is XY. Our X is going to stay the same. However, our Y is going to be plus 3. That means we're going to just move it up 3. This figure just gets moved up 3. So Q gets moved up 3, so Q gets moved up to here. R gets moved up to here, because you just count them out. S gets moved up to here. And P gets moved up to here. So we have like this little red kite looking figure. The tip of that kite is on the x-axis, so we look at A, well that's incorrect. C, P prime is not on the x-axis. It is for D and not for B. So our answer is D. Let's bring it up a little bit. So P is on that x-axis, here and here. Now let's look at number 3. I could actually make that picture a little bigger. There we go. So in this figure, we're going to take our original coordinates, what we have here in black, and we're going to move it to the right 1. And we're going to not go up and down because we're doing nothing with the y. So C, move to the right 1 is here. D, move to the right is D prime right there. B, and there's your B prime. And here's your E prime. So this little parallelogram is moved to the right 1. It looks like that, what you see in blue. As far as multiple choice, it's C. Let's just move to the right 1. Oh, sorry, it's D. So far as multiple choice, come on. It'll be D right there. Looking at number 4 for another example. So we take our original XY, our little trapezoid here. We're going to move it to the right 6 and down 2. So let's take our I, 1, 2, 3, 4, 5, 6 to the right, down 2. That's the location of I prime. J is right underneath I, so if we do 6 to the right, 2 down, our J prime will be right there. H, we move that one 6 to the right, 2 down, so that's the location of H prime. G, we go 6 to the right, and 2 down. There's our G prime. And that's what our answer looks like. So then we compare our answer with the multiple choice that we have. What we have here in blue is the picture we're going to be looking for. Number 5. We take our original picture. We go 2 to the left. The reason why, because if it has x minus 2, that's saying 2 to the left. If it was plus 2, it would be 2 to the right. And then we have y plus 1. That means we're going to move our figure up 1. So 2 to the left, 1, 2, up 1, right there. There's our M prime. L prime, 2 to the left, up 1. N prime. And K prime. Connect them up. Make trans right here into blue. Number 6. So we take our original figure, we're going to move it to the left 6 and up 7. So T and move it to the left 6. 1, 2, 3, 4, 5, 6, up 7. There's my T prime. R prime is just 1 to the right, so it's 1 to the right here. S prime is just 1 above R prime. So there's our blue triangle. And we're going to look for our blue triangle here in the multiple choice, which it looks like it's B. Classic that we did in class, 1-4-CW1. So you could try doing that classwork again and then submitting it on Google Forms to see which ones you got right, which ones you got wrong, as far as improvement. These translations can get a little harder, so let's talk a little bit about those now. So let's say we have something like this. This is the same style of problem. However, the presentation is a little bit different. And let's just walk you through this. So it's the same concept, it's just the presentation is a little bit different. You can handle it. So if they have triangle FGH is translated to MNP. Given that F is 3, 9, so we're going to mark some of these points. 3 to the right, 9 up. 1, 2, 3. So that's our F coordinate right there on our grid. G is negative 1, 4. So negative 1, 4. And our M is 4, 2. So 1, 2, 3, 4, up 2. So FGM is this triangle right here. And P, 6, negative 3. Oops. So it's not a triangle. So P is 6, negative 3. So 1, 2, 3, 4, 5, 6, negative 3. Find the coordinates of H and N. Oh no, it was a triangle. Silly me. So now, something that you need to know. The presentation of triangle FGH, this order does matter. F goes with the first letter of the other triangle, M. G matches up with N. H matches up with P. So if we're given P is 6, negative 3, P is the third letter in MNP. So P matches up with H. So we got to find a translation between H and P. Oh, pardon me. They really didn't make this tougher. As far as presentation, okay. So, everything matches up. So, F, G, and H. So, F, G, and H go together. And then M and P, so M, N, and P. M is 4, 2. And P is 6, negative 3. So these two go together. And these two go together. So it's one side of one picture and the other side of the other picture. A little on the extra challenging side. So F and G. H, we don't know the location. And M and P, we don't know the location of N. Alright, so we could see that F matches up with M because it's the first letter and the first letter. So F is 3, 9. So let's label that F. And M is 4, 2. 1, 2, 3, 4, 2. So what happened here? It looks like it went 1 to the right and then 1, 2, 3, 4, 5, 6, 7 down. So 1 to the right and then 7 down. So it'll be x plus 1 comma y minus 7 going from F to M. So we're going to look at this other coordinate here, G. And we're going to go 1 to the right and then 7 down. And now we'll create our other point N. Whoops. So M and P. And then we kind of need to do the reverse of P. Since this was the result, this was the after, or the image, to do the reverse, we got to go up 7 to the left 1.